Hello, welcome to this video on development of surfaces. So in this video we look at a particular problem. So there are two aspects that we have to look at. Number one, what is the solid given? In this case it is a prism of base, pentagon, 30 mm sides. Height of the prism is 50 mm. The prism has to be placed in such a way that one of its rectangular faces is inclined at 30 degrees. The second part, the question is, it is cut by a section plane inclined at 60 degrees to HP, perpendicular to VP. It has to pass through a point on the axis 30 mm above the face. Before we go to solve the problem, we should understand what are the basic aspects. I'll just repeat for your understanding. A general solution in the problem on development of surfaces involves these four aspects. Number one, we need to draw a set of front view and the top view. That's the orthographic projection of the solid. Next, for the given solid, you need to indicate the basic development. You have to lay out all the lateral surfaces. Then you have to indicate or introduce a section plane that involves identification of section points and which are all, what is the portion to be cut, what is the portion to be retained, and transferring all these points onto the basic development in order to get the final development. So for this problem we'll start our projections with the first part, identifying the solid, writing down what is the prism. So we'll look at the drafting part of this. So we start with a normal line. Initially we should draw all lines that are thin lines. So you would introduce the XY, VP, HP. You need to draw the front view and the top. Now you will be required to draw a pentagon in such a way that one of the sides of the pentagon makes an angle of 30 degrees. So if you look at the requirement over here, it says you need to draw pentagon in such a way that one of the rectangular faces has to be inclined at 30 degrees to VP. That means in the top view, the pentagon should have one of its edges inclined at 30 degrees to VP. So I would reduce it. So I have drawn a pentagon in such a way that you have one of these edges of the pentagon making an angle 30 degrees in the top view. So we'll do the naming of this endpoints in this fashion for a prism, and I'll try to identify the location of the axis. I'll draw any two medians to find out the centroid. So once we get these points in the top view, then we shall try to create the front view. So you draw projectors from each of the corners up, then get the vertical edges, top face and the base in the front. So in the front view we have visible lines corresponding to this corner over here, then 2, 3, 4. There are 4 corners visible in the front, and corresponding to E1 you have a hidden line over here and you have an axis over here. What we need to understand in development of surfaces is until you draw the section plane and the section points, in the initial set of constructions have to be drawn using thin lines only. Now we shall do the naming of the points in the front view. These are the set of points on the top face. and these are the points on the base. Now first task, once we draw the front view and top view of the solid in the given position, we will have to do the basic development. So this is a prism. You would be making use of the parallel line development, and you would reproduce the 5 rectangular faces of the prism in their two shape. So I will be making use of these two parallel lines in order to develop 5 rectangular faces. So this is our first rectangular face. We shall name this. The naming would be done like this, and on the development over here you will have to do the naming of the points in capital letters. Now this is one of the faces which has a width of 30 mm, height of the face is 50 mm. Now for the basic development we will have 5 such rectangular faces because this is a pentagonal prism. Now I shall represent 5 faces, do the naming. So I have 5 of these faces totaling to a length of 150 mm, then let me also complete the naming. So this is how we do the naming. Once you do the naming, you have to ensure that the last set of points would be same as the first set of points over here. So again, this is a pentagonal prism, so you have edges at A, B, C, D, E. There is no F here. The last set would be same as this A and A1. So this is what we call as the basic development. The next part in this problem, we also have a section plane to be introduced. So we'll look at the details. The next part, we have a section plane which is inclined at 60 degrees to HP, perpendicular to VP, and it has to pass through a point on the axis 30 mm above the base. So this I have to show on the projection over here. So we need to introduce the section plane in the front view here. That makes an angle 60 with HP, that means 60 degree with XY line. It is perpendicular to VP, that means you will see it as a straight line in the front view. And where would that be passing? It has to pass through a point on the axis 30 mm from the top face. 30 mm above the base. So from the base I have to identify a point on the axis 30 mm above the base and introduce the section plane over there. So this is how I do it. I shall locate a point 30 mm from the base on the axis. Then I would introduce the cutting plane at this particular point over here. This is how I introduce the section plane. So when we write the section plane, we have to make sure that this line is represented as a center line. And number 2, the two end dashes. The longer dashes at the ends of the line should be shown as thick lines. So that's the way we represent the section plane. So once we introduce the section plane, the next part is to identify which are all the edges cut by this section plane. So we'll take a closer look at this and try to identify which are all the edges cut by this plane. So I'm just taking a zoom view of this. Okay. Now we shall see which are all the edges cut by this section plane. Now here we have the pentagonal prism. Now if I look at this edge, AA1 is not cut by the plane. PB1 is cut at some portion over here. You can make out. Then CC1 is not cut. So it's only this portion. This is the line that is cutting the prism. So CC1, DD1 are not cut. So, and this edge at the back EE1 is also cut by the plane. So, and in addition to that, now if you look at the top face here, the top face is cut by the plane over here. And similarly, if you look at the base of the object, the base is also cut. Now if we observe close towards this point over here, we can see that this is the edge BB1. BB1 is also cut, and some part of this base is also cut by the plane. Now once we introduce the section plane, the next part is to identify the section points. You have to identify which are all the edges cut, and you also have to identify the section points. Whenever an edge or vertical edge is cut by the plane, it cuts the edge at one particular point. On the top face and the base, you will always have two section points. So we will have to identify those points. Now I'll just represent them in an order starting from the base here, and I move in the clockwise or move from the front and go then towards the back. So I'll represent these points both in the front view as well as the top view. This is how we represent the points. I'll start with 1 on the base, then 2 is on the edge joining BB1, then next set of points are 3 and 4 on the top face over here, cutting between P and C, and 1 between D and E. Point number 5 is on E1 at the back, so it's shown as a hidden point, and 6 on the base on the line or edge joining A1 and E1. Considering that we take out the top portion, we retain the lower portion. This is the way section plane is represented. The direction of arrows shown over here indicate which portion of the prism is retained. So I'm going to darken now all the edges of the prism that remains in the lower portion of the section. So once I darken this portion which is being retained, you can also add this a closer look that tells you which are all the points that are cut. 1 and 6 on the base, 2 is on BB1, 3 and 4 on the top face, and 5 is on E1. The next part of our constructions would be to put these points, all these 5 points, in their 2 locations on the basic development. Then you have to complete the development of the truncated portion. So in order to represent point 5, for example, point 5 is at E1. Since E1 in this view represents the true shape, I can straight away project this point 5 onto E1. This is where you have the line joining E and E1. Similarly, I can also project point number 2 straight away onto BB1. So it appears, let's take a closer look at this. So 2 appears on this, at the intersection of these 2. So I should copy. So I'll have this point 2 over here, this location. In order to represent these points, 1, 6 and 3, 4 on the top face and the base, since the edges joining the corresponding points, they are not in true length. In this case, what we have to do is we need to project these points onto the top view. Now we should try to project these points into the top view. Now if you look at point 2, would be on the line joining B and B1, that's over here. Point number 5 is at the line joining E and E1. Now if we take this point 3, 4, try to take a closer look at this. Now 3 and 4 is on the top face. So if we try to project this point in the top view, Now this section plane would cut the top face at 2 points. One over here, line joining D and E, and another at location between line joining B and C. So essentially we have our point number 3 over here and point number 4 over here. So point 3 is at a distance of this small distance between B and C. Similarly, 4 is at this distance from location E. Likewise, if you try to plot this point, for example 1 and 6, you see here, so 1 and 6 are on the base. And if I try to project this point over here, it cuts line joining A1 and E1 on the base at this point 1, and the line joining B1 and A1 at this location over here. So this is essentially our point number 1 over here, and this will be point number 6. So what we need to do is identify at what distance these are from various corners, and then we need to transfer these points onto the basic development in order to obtain the truncated portion. Now here I have identified the actual distance of these points, 1 from corner B1, similarly 3 from C1, it's about 1 mm. This point 4 is at a distance of about 12 mm from E, and point number 6 is at a distance of 7 mm from A. So I need to transfer all this onto the corresponding edges. We'll try to represent them and then connect the points. Point number 1 is at a distance of 1 mm from B1 over here. Point 2 is on BB1. This point number 3 is on line joining B and C. So it will be coming somewhere here at a distance of 1 mm from point C. So I mark point 3 over here from C. And then we have 4 on the line joining D and E at a distance of 12 mm from E. I will represent that. So I represented 4 at a distance of 12 mm from E. Then this point 6 is on the line joining A1 and E1 at a distance of 7 mm from A1. So here I have represented 6 at a distance of 7 mm from A1. Now what we are supposed to do is, in order to get the actual development of the truncated portion, we need to join all these points and complete the border. Let me connect this. So I'll start with this point 1, then 2, then we have 3, goes like this till 4, then 5, 6, and this is the border. Take a closer look at this part. This is what we have. Then since the edges joining CC1, DD1 and EE1, they represent physical edges of the prism. They are not partially, some of them are full not cut, and E1 is partially cut. Since this portion is retained, E1 BB1 here, you have to darken this. So finally, this represents the development of the truncated portion of the prism. Here, certain more things you need to observe. These dimensions that I indicated earlier need not be shown, since you will be showing it manually. And while naming these points on the development, it is always a practice to add a suffix 1 to all the points that appear along the section. Thank you for watching this video.